Alright, so now we're going to solve the remaining part of this paper, which is May-June 2020, paper 1, variant 2. So we resume from question number 14, which says in 2017 the population of Egypt was 97,500,000, and we have to write this in standard form. So we're going to start moving the decimal towards the left, and let's do that. So we have 1, 2, 3, 4, 5, 6, and 7. So since we've moved the decimal 7 places towards the left, the power is going to be, the answer is going to be 9.75 times 10 raised to the power positive 7. If the decimal is moved leftwards, the power is positive. If it is moved rightwards, the power is negative. Part B says the population density of a country is the number of people per square kilometer. In 2017, the population of Indonesia was 2.62 times 10 raised to the power 8. Correct to 3 significant figures. The area of Indonesia is 2 times 10 raised to the power 6 kilometers square. Correct to 1 significant figure. Population density is basically the number of people divided by its area. So we have to calculate an estimate for that. So let's take the population in the numerator, which is 2.62 times 10 raised to the power 8, and divided by the area, which is 2 times 10 raised to the power 6. So if we evaluate this, so we're gonna an easy way to remember how to solve standard form questions in which we have to divide is that you have to compare apples with apples and oranges with oranges. And what I mean by that is we're going to divide the power 10s and then we're going to divide the numbers that we have before that. So 10 power 8 divided by 10 power 6 is going to be 10 power 2, since 8 minus 6 is 2, and then we have 2.62 upon 2. So I can first multiply 2.62 by 10 square, which is basically 100. So this is what this is going to turn into, 2.62 multiplied by 100 upon 2. So if I multiply 2.62 by 100, that's going to give me 262, and then if I divide this by 2, so that's going to give me 131. So my final answer is going to be 131 people per square kilometer, and that's the population density of Indonesia. Okay. So we move on to question number 15, and this is related to inequalities. And let's see what we have to do. What we have to do here is we have to find the 3 inequalities which define the shaded region. Okay, so the best way to solve questions related to inequalities is that you should always start by numbering your line. So I'm going to call this line 1, and I'm going to call this line 2. And I'm going to call this line 2, just so that it's easy for you to know what line I'm referring to. So we start by line 1, and line 1 is just a positive sloping line. So that means I'll have to figure out what the gradient is and what the y-intercept is. I can see what the y-intercept is, it's 1, but I still have to figure out what the gradient is. So in order to do that, we'll have to pick 2 points through which this line is passing. So I'm going to take 0, 1, and I'm going to pick this point, which is 2, 3. You can pick any 2 points that you like. Let's figure out the gradient, which is y2 minus y1 upon x2 minus x1. So 3 minus 1 upon 2 minus 0. So that's going to be 2 upon 2, which is equal to 1. So the gradient is 1, and the y-intercept is also 1. So our equation is going to be y equals to x plus 1. Okay, so that was line 1. Now let's talk about line 2. So as far as line 2 is concerned, line 2 is a horizontal line. So the equation of line 2 is going to be y equals to the point at which it's passing through the point at which it cuts the y-axis. So that's going to be y equals to 3. And let's talk about line 3. Line 3 is a vertical line, so its x value is fixed, and its equation is going to be x equals to something, and that something is going to be 5, since that's the point at which it's cutting the x-axis. So the equation of line 3 is x equals to 5. Okay, now we have to define the shaded region by inequalities one by one. So we start by line 1, which has equation y equals to x plus 1, and if we look at the shaded region, we can see that it is below the line. So below the line means it's going to be less than, and not only less than, in fact it's going to be less than or equal to, since the line is a solid line. So we're going to have y is lesser than or equal to x plus 1. So let's start writing them in the answer space. Y is lesser than or equal to x plus 1. And then if we talk about line 2, so the shaded region is above line 2, so that means it's going to be greater than or equal to the equation. So it's going to be y is greater than or equal to 3. And then let's talk about line 3. So we can see that the shaded region is towards the left. That means the x values are going to be less than or equal to 5. So we're going to have x is lesser than or equal to 5. Let's just quickly double check. Line 1, x plus 1 less than, that's fine. Line 2, y is greater than or equal to 3. Line 3, x is lesser than or equal to 5. Yep, that's correct. Okay, now let's do question number 16, which says that Q is a subset of P. So that means when I'm drawing set Q, it has to be inside set P. So this is going to be set P. And then P intersection R are two sets such that they are disjoint. That means they have no intersection. So that means when I'm drawing R, let me just write that first, no intersection. So when I'm drawing set R, I'll make sure that it doesn't overlap with P at all. So this right here is going to be set R. Okay, now let's do question number 17, which is related to number sequence. Let's see what the pattern is. So we have T1 is equals to 1 square plus 3, which is equal to 4, and then 2 square plus 8, which is equal to 12. Okay, 3 square plus 13 is equals to 18. Oh, so sorry, 3 square plus 13 equals to 22, 4 square plus 18 equals to 34. Okay, so it's always best to rewrite the pattern. So we have 1 square plus 3 equals to 4. We can see that the first term is always equal to the you can say the line of the pattern. So if you're talking about the second line, so it's going to start off with 2, and then we're going to have 8 equals to 12, and then as far as T3 is concerned, so that's going to be 3 square plus 13 equals to 22. T4 we can see is 4 square plus 18 equals to 34. And then T5, according to the pattern, the first term is going to be the same as the value with T. So that's going to be 5 square. And then if we follow the pattern in the second column, so we can see there's a constant difference of 5. So 3 plus 5 is 8, 8 plus 13, 8 plus 5 is 13, 13 plus 5 is 18. So that means the next term is going to be 5 greater than 18, and that's going to be 23. And then we can evaluate what 5 square plus 23 is going to be. So that's simply 25 plus 23, and that's going to be 48. So there you have it. T5 is going to be 5 square plus 23 is equal to 48. Okay, now, and since the question is asking for just T5, so our final answer is going to be 48 only. So let's erase all of this and let's just stick to 48. Okay, now, then the question says find an expression in n for Tn. So that means now we have to find the general term. Okay, so when we're finding out the general term, what we're going to do is we're going to take the end values, which are 4, 12, 22, 34, and 48, and we're going to find the nth term of this sequence. Okay, so I've already made a video on how this is basically a quadratic sequence, and I've already made a video on how to find the general term or the nth term of a quadratic sequence. So let's do that quickly. We take the difference between the first two terms, and that's going to be 8, and then the next two terms, and that's going to be 10, and then the next two, that's going to be 12, and then the next two, that's it, that is 14. So the difference of the difference, or d2, is 2, and that is constant, that's not changing. So the formula for the quadratic sequence is this: Tn is equals to a plus n minus 1 times d2 plus, sorry, times d1, which is the first difference, that means difference between the first two terms, plus d2 upon 2 multiplied by n minus 1, n minus 2. So I'm just going to plug in the values. The first term is 4, the first difference is 8, and the difference of the difference is 2. So this is going to be 4 plus n minus 1 times 8 plus 2 upon 2, and then if you expand n minus 1, n minus 2, you're going to get n square minus 3n plus 2. You can just memorize the expanded version, that's going to save you a lot of time. So these two get cancelled out, and then we have 4 plus 8n minus 8 plus n square minus 3n plus 2. Okay, now let's see, let's try and simplify this. So we have n square, and there's nothing to simplify, add or subtract with n square. 8n minus 3n is going to give me positive 5n, so n square plus 5n. 4 minus 8 is going to give me minus 4, and then minus 4 minus 8 is minus 4, minus 4 plus 2 is going to give me negative 2. So we have n square plus 5n minus 2. So there you have it, that is the general term of the sequence above. Okay, let's do question number 18. This is related to kinematics. So the diagram is the speed time graph for part of a car's journey. All right, the deceleration of the car between t equals to 140 to t equals to 200 is 0.2 meters per second. So that means the gradient of this line, and remember, since it's deceleration, so the gradient is going to be minus 0.2. And if you have to find the value of v, we're going to have to use the gradient. So let's take these 2 points, the one that I've highlighted. So this point is going to be 140 comma v, and this point is going to have coordinates 200 comma 0. So the gradient of this line is going to be minus 0.2. So let's see, y2 minus y1, so v minus 0 upon x2 minus x1, which is 140 minus 200, is going to be equal to minus 0.2. So this is going to become v upon minus 60 is equals to minus 0.2. 60 times minus 0.2 is going to be 12. Yep, so the answer is positive 12. So let's just write this here, 12 meters per second. Yeah. Okay, so part B says the car travels a total of 1800 meters in 200 seconds. Okay, so bear in mind that since this is a speed time graph, its gradient is equal to acceleration or deceleration, and its area is going to be equal to the distance traveled, which is 1800. So this shape we can see is a trapezium, so the area of this trapezium, the one that I am highlighting, is going to be equal to 1800. So how do you calculate the area for trapezium? Well, half into sum of parallel lengths. So the parallel lengths here are going to be the two horizontal lengths that we have. So this length starts from 0 and goes all the way to 200. So this is going to be 200 plus the length that is parallel to it. So this length we can see starts at t and goes all the way to 140. So hypothetically speaking, if t were 40, so the difference between 40 to 140 would have been 100 by this we would have obtained by subtracting 40 from 140. But since we don't know the value of t, so the difference, or you can say the length of the line, is going to be in terms of t only, and that is going to be 140 minus t. So 200 plus 140 minus t. So this is the sum of parallel lengths multiplied by the height. So the height is just the vertical, the perpendicular distance between the two parallel lengths, which is equal to v, and that is something that we have already figured, and that is 12. So multiplied by 12 is equal to the total distance, which according to the question is equal to 1800. Okay, so let's start simplifying this. 2 ones are 2, 2 6 are 12, 6 ones are 6, 6 300s are 18. So we have 200 plus 140, which is going to be 340 minus t multiplied by 1. So there's no point in writing that. In fact, there's no point in making a bracket anymore, is equal to 300. So t is going to be equal to 340 minus 300. So t is equals to 40. Yeah, just 40. Okay, so that's that. Let's do question number 19 now, which is related to vectors. So we have two vectors p and q, which are shown on the grid, and on the same grid we have to draw 3p, and we also have to draw q minus p. Okay, so if I want to draw 3p, that means I'll just have to take this vector and triple it, or you can say times it by 3. So before I do that, I'll have to check what the rise is to run ratio is. So I can see that the run ratio is 2. For every 2 units of run, there is 1 unit of rise. So if I have to multiply this by 3, that means 3p will have 6 units of run and 3 units of rise. And how did I get that? Well, I simply got that by multiplying these two numbers by 3. Okay, I'll just do it here on the side. 2 is to 1, and then if I multiply this by 3, so that's going to give me 6, 3. So I can draw this anywhere on the grid. So if I start from here, so 1, 2, 3, 4, 5, 6, and then 1, 2, 3. So there you go. This vector is basically 3p. Okay, and then we have to draw q minus p. All right. So if you want to draw q minus p, there's one way to do this would be that you can what you can do is you can first figure out what q is in terms of x and y. So q is 1 since it's towards the right, so it's positive 1, and then let's see how many units downwards do we have to move. So that's 1, 2, 3, so that's minus 3. So 1 minus 3, that's q, and from this let's subtract p. So if I subtract p from this, p as we saw is 2, 1. So there you go. So 1 minus 2 is going to be minus 1, and minus 3 minus 1 is going to be minus 4. So that means if I'm drawing a vector q minus p, so I'll have to move 1 unit towards the left and 4 units downwards if I want to go from the starting point to the finishing point. So let's mark anywhere on the grid a starting point. Let's say this right here is a starting point. So this is 1 unit towards the left, and then 1, 2, 3, 4. So this is our vector q minus p. Okay, so that's that. Let's do question number 20 now, which says a plan of a house is drawn to a scale of 1:50. On the plan, the floor area of kitchen is 30 centimeters square. Calculate the floor area of the real kitchen. Give your answer in square meters. Okay, so first let's calculate this in centimeters square, and then we can always convert it later. So this, remember, is for the plan, and this is for the actual. So 30 is on the plan, so I'm going to put it under 1, and then for the actual it's going to be x. And if you do it like this, you're going to end up making a very common error and you'll get the wrong answer. So basically I'll tell you why that is. Because the scale that we have is only suitable for converting lengths. So if you want to be able to use this scale in order to convert area, what you'll have to do is you'll have to square both sides. So once you square both sides, you know that 1 centimeter square of area is going to be equal to 2500 centimeters square of area in actual. So now I can plug in, now I can place 30 just under 1, so 30 centimeters square. And then what's the actual area? We don't know that, so we're just going to write x here. So 2500 times 30 is going to give me 75, since that's what 25 times 3 is, and then I'm going to place 3 zeros, centimeter square. Now how do you convert centimeter square to meter square? Well, if you want to convert centimeter to meter, you divide it by 100. But if you want to convert centimeter square to meter square, you have to divide it by 100 square, which in other words means dividing by 10,000. So 75,000 divided by 10,000, let's see what is that equal to. So first of all, the 3 zeros get cancelled out, and then we just have 75 divided by 10, which is going to be 7.5 meter square. Okay, now let's do question number 21, which is 2x square upon x power 5 raised to the power minus 3. So one way to do this would be, actually the first thing you should do here is you should turn the power from negative to positive. And how can you do that? You can do that by taking the reciprocals. So x power 5 over 2x square, the whole thing cubed. So you can either cube it first and then simplify the brackets, or you can simplify the bracket first and then cube the final answer. So if I simplify the bracket first, that means I have x power 5 in the numerator and x square in the denominator. So we have same bases that are being divided, so I'm going to subtract the powers. This is going to become x raised to the power 5 minus 2, and the 2 in the denominator is going to be left as it is, and then don't forget to cube the final answer. So we have x cubed upon 2, and the whole thing is being cubed further. So x cubed cubed means that the powers are going to get multiplied, and 3 times 3 is going to be 9. So we have x to the power 9 divided by the cube of 2, which is going to be 8. So our final answer is going to be x power 9 divided by 8. Okay, now question number 22, which is f of x equals to 4 into 3 minus x, and then we have g of x, and the first part says find f inverse of x. Okay, so first let's find out what f of x is. I mean, let's multiply the brackets. So we're going to have 12 minus 4x. Now let's find the inverse. So the first thing I'll do is I'll set it equal to y, and then I'll have to make x the subject. So let's try and get x positive first. So I'm going to bring 4x on the left hand side and y on the right, and let's make x the subject now. So 12 minus y upon 4, and then the third and the final step, which is that you replace x with f inverse of x and y with x. So there you have it, 12 minus x upon 4. Okay, now let's do part B, which says solve g of x equals to 6. Okay, so all I got to do here is set g of x equal to 6 and solve for the value of x. Okay, no big deal. So 15x minus 10 equals to 6x. Let's bring 6x on the left hand side, so that's going to be 9x equals to 10. So x equals to 10 upon 9, and let's just write the answer as it is, 10 upon 9, or you can even write it in as a mixed number. Okay, let's do question number 23, which is expressed as a single fraction in its simplest form. So in a question like this, we'll first have to take the LCM, which we can obtain by simply multiplying the two expressions, 2x minus 1 upon x plus 4. And then 5 is going to get multiplied with x plus 4, so this is going to become 5 times x plus 4. minus 3, and this is going to get multiplied with 2x minus 1. So there you have it. And then let's simplify this further. So 5x plus 20 minus 3x. Now be careful, minus 3 times minus 1 is going to turn into positive 3. And then it's up to you whether you want to expand the denominator or not. So I'm going to leave it as it is. So 5x minus 3x is going to be 2x, and 20 plus 3 is going to be this 3x into 2x is going to be minus 6x. Yeah, there's something wrong. So 5x minus 6x is going to be minus x plus 23, and then you can leave the denominator as it is. Alright, so let's just write this here, and in fact let's just write this as 23 minus x. This looks a lot nicer, times 2x minus 1 into x plus 4. There you go. Okay, now let's do question number 24, which is the second last question. And so if you have a point that's lying on this line, so all you got to do is you got to plug in its coordinates, x in place of x and y in place of y. So I'm going to plug in 7 in place of y and h in place of x, which is equal to 5. So 21 plus 2h equals to 5. 2h is equal to 5 minus 21, which is going to be minus 16. Yep. And h is going to be minus 16 divided by 2, which is going to be minus 8. So there you go. Then the question says line L is perpendicular to the line 3y plus 2x. So let's just underline the word perpendicular. 3y plus 2x equals to 5 and passes through P. Find the equation of the line. Okay, so this is a 4-mark question. So if a line is perpendicular, the first thing you got to figure out is the gradient, and you can do that by first of all obtaining the gradient of this line, the equation of which is already given. So 3y equals to minus 2x plus 5, and y is equals to minus 2 upon 3x plus 5 upon 3. So the reason why I've written this 3 separately with every value is so that I can see what the gradient is. So the gradient of this line is minus 2 upon 3, and if you want the gradient of the line that's perpendicular to this one, you will have to take the negative reciprocal of this gradient. So the negative reciprocal of this gradient is simply going to be 3 divided upon 2. So now that we have the gradient, we're going to have to figure out, we need a point through which the line is passing so that we can obtain what C is, and that is already given to you, and that is P. And we already have the coordinates of P now, which are minus 8 and 7. So minus 8 and 7. So I'm going to plug in 7 in place of y and minus 8 in place of x to obtain the value of C. So 2 1s are, 2 4s are. So 7 is equals to minus 12 plus C. So C is going to be equal to 7 plus 12, which is 19. So y is going to be equal to 3 upon 2x plus 19. There you go. Now let's do question number 25, which is the final question of this paper. So evaluate 2a minus another matrix. So let's do that. This is pretty simple. So 2 times 2, 0, minus 3, minus 1, minus 5, 4, 0, 3. So 2 into 2 is 4, 0, minus 6, minus 2. Just got to be careful here. 2 times 2 is 4, 0, minus 6, minus 1. Yeah, no harm in double checking. Minus 5, 4, 0, 3 as it is. So 4 minus minus 5, 4 minus minus 5. So that's going to make it 4 plus 5, which is going to be equal to 9. 0 minus 4 is going to be equal to minus 4. Minus 6 minus 0, so that'll just remain minus 6. And what do we have next? Minus 2 minus 3. Minus 2 minus 3, so that's going to be minus 5. Okay, now let's find, this means that we just have to find the determinant of A. So if I want the determinant of A, let's just rewrite A here. 2, 0, minus 3, minus 1. And you must know that the determinant of A is basically equal to AD minus BC. So AD is going to be minus 2 minus 0. So that's simply going to be minus 2. Okay, then you have to find A inverse. So how do you find the inverse of a matrix? 1 upon its determinant, and then you swap A and D, and then you change the sign of B and C. Let me just write that neatly. Minus B minus C. Yeah. So 1 upon the determinant of matrix A, which is going to be 2, and then I'm going to swap A and D, so that means in place of 2 I'll have minus 1, and in place of minus 1 I'll have 2, and then changing the sign of 0 won't make any difference, so I'll just write 0, and then changing sign of minus 3 is going to turn it into 3. So I can either leave this as it is, or its determinant is minus 2, sorry, it's not 2. I can either leave this as it is, or I can multiply every value by minus 1 upon 2. So I can either leave it like this, or this is going to become 1 upon 2, 0, minus 3 upon 2, and minus 1. This is what you will obtain if you multiply it by minus 1 upon 2. So I'll just write the multiplied version. So 1 upon 2, 0, minus 3 upon 2, and minus 1. Find the matrix X where X times A is equals to 4 minus 2. Okay, so if you want to find out X, that means you'll have to take A on the other side, and since A is written after X, if it moves across the equals to sign, it's going to become A inverse. But the question is, where should I place A inverse? And the answer to that is, you're going to place A inverse right after this matrix, which is 4 and minus 2. So X equals to 4 minus 2, and at this point I'd prefer to use this form because it's going to be easy to work with. So minus 1 upon 2 on the outside, minus 1, 0, 3, 2. Okay, so what I'm going to do here is I'm going to bring minus 1 upon 2 towards the very left, and then I'm going to multiply these two matrices together, and then towards the end I'll multiply the values by minus 1 upon 2. So multiplying these two matrices means row into column. So 4 times minus 1 is going to be minus 4, plus minus 2 times 3 is going to be minus 6. So there we have it. And then we're going to multiply this same row with this column. So 4 times 0 is going to be 0, plus minus 2 times 2 is going to be minus 4. So now we have minus 1 upon 2 multiplied by minus 10, and then 0 minus 4 is going to be minus 4. So minus 1 upon 2 times minus 10 is going to be positive 5, and minus 1 upon 2 times minus 4 is going to be positive 2. So let's just write our answer here, 5, 2. And there you have it. We've solved the entire paper, and I hope everything's clear. In case it's not, let me know in the comment section, and I'll see you guys in the next video with another past paper. Until then, take care. Bye bye.